Yes, very good morning, dear students. Welcome back to online physics class, grade 10. Yes, dear students, so far we are discussing a few concepts from this magnetic effects of electric current. And last lecture we are discussing about important concept that is about how we define magnetic field and how we can represent magnetic field lines for any bar magnets. Right, and today also I'm going to discuss very important concept that is magnetic field due to a current carrying straight conductor. So in current carrying straight conductor, how magnetic field will be exist and what are the direction of magnetic field lines? Just you can remember magnetic field is a vector quantity. It have magnitude is there and it have direction also will be there. Right or not? So this the direction of magnetic field in from magnetic field lines we seen it will be outside of the magnet. It will be north pole to south pole, and it inside the magnet south pole to north pole. Right here, how the direction of magnetic field will be exist, and how magnetic field. First we want to know magnetic field will be exist or not for current carrying conductor. Just we know very well magnetic field surely will be exist whenever carrying conductor will be there. For conductor having current, so then magnetic field will be exist, that we know already. So now first before that I want to discuss once again. So the direction of magnetic field is from north pole to south pole outside the magnet, and from south pole to north pole inside the magnet. That we know already, that already discussed in last lecture also. Just again I'm discussing here about that point in the note point. So now magnetic field due to a current carrying straight conductor. So for example, before that just I want to see you these are three diagrams, right? See, dear students, it is a straight conductor. So here also A, B, say given three diagrams, straight conductor. For example, just I am taking a sheet, right, and it is connected. It is connected to ammeter. It is a positive charge to negative charge. The positive terminal to negative terminal current is passing. It is ammeter A, dear students, and it is connected to rheostat, variable resistance, and it is connected to plug key, and again it is connected to a straight conductor. So this straight conductor current is going from positive terminal to negative terminal. It is a positive side and it is a negative side. So whenever a current carrying conductor, it is connected to a paper. For example, if you take a sheet of white paper. But now how a magnetic field will be traced? Of course, here current will be passing through a conductor, straight conductor. So to trace a magnetic field, at least we require two things. So one is maybe a compass needle. If you place a compass needle near the straight conductor, then it will be shows deflection. Then we can detect. Then we can conclude, yes, a current carrying conductor produces a magnetic field. Then a compass needle shows deflection. So from compass needle shows deflection, current carrying conductor produces magnetic field. Or else one thing also I did last class. So whenever if you sprinkle iron fillings, right, so when if you sprinkle iron fillings, it make a concentric circle. It means it will be move. Iron sprinkle means, so it behaves itself as a magnet. So this is a two process how we can trace a magnetic field. See, just it is a demonstration for this. So after that, see, it is like this, means it is a circuit is connected. Just I place like this in the form of like this. So it is nothing but a circuit is connected here. Here current is passing, right? So here also I am taking one sheet of paper. Here I sprinkle a, what is that, iron pieces. Then it make a concentric circle. It makes a constant. It revolves around a circle. So it is nothing but this iron. This iron pieces behaves is like a magnet. Then it will be shows deflection in the form of a concentric circle. So here you can see. So how it will be? It is a clockwise direction or anti-clockwise direction. See, it will be here. So whenever the current is traveling from positive to negative, so it behaves anti-clockwise direction. It is a traveling along anti-clockwise direction. See, we know very well. It is a 6. It is a 12. So it is a clockwise direction. So it is here. It behaves like this. It behaves like this. It is nothing but what, anti-clockwise direction, right? Yes. So in third one you can see. Here now I reverse the current direction. Before here it is a negative and positive. Here I, how it is means it is a positive and it is a negative. So then it will be reverse direction. The direction of a magnetic field also will be reverse. Now it will be, so before it is like that. Now it is like this. Now it is like this. Here it is a clockwise direction. So how when current carrying straight conductor produces magnetic field, and how this iron sprinkle behaves a magnet and revolves around a concentric circle. It is a concept from magnetic field due to a current carrying straight conductor, dear students. So why I am before introducing these diagrams means related to these diagrams only we want to discuss the concept. So that I am taking, when a current is passed through a straight conductor conducting wire, a magnetic field is produced around it. So the magnetic needle can be traced by mean of iron fillings or a small compass needle. That only it will important point. The magnetic needle be traced by means of iron fillings or a small compass needle. And now you take a thick straight conductor. It is about diagrams. Take a thick straight conductor, copper wire XY, and connect it through the rheostat or H and a key K and ammeter A, so that current flows from Y to X. So when we sprinkle some iron fillings on the cardboard, it is like I told a sheet of white paper, it is a cardboard. So these arrange themselves in concentric circles around O when the cardboard is gentle tapped. So these concentric circles represents the magnetic field lines, and this is shows that there exists a magnetic field around a straight current carrying conductor, and it is in the form of concentric circular field lines with the conductor at the center. So this is about so magnetic field due to current carrying straight conductor. So in other words, to know the direction of magnetic field, we plot the field lines with the help of a compass needle. Already last lecture I told you how in another way means, if you take compass needle, if you put a compass needle over the north pole, it shows deflection, and you remove that compass needle, you take one dot, again you keep there, again it shows like that, right? Yes. And that the north pole of the compass points in the direction of the field at any point. So for example, if you want to find out the direction means, you can take any tangent at the north pole, and the tangent at the point it gives the direction of the magnetic field. I shown already, I discussed last lecture itself. And here the direction of the field lines is anti-clockwise in figure B, that I discussed already. In figure B it is anti-clockwise. And if the direction of the current is reversed, so that the current flow x to y, and the direction of the field line is also reversed. Here these field lines are clockwise direction in figure C. This is about, dear students, magnetic field due to a current carrying straight conductor. So here we want to observe magnetic field have a magnitude is there and a direction is also there. And how we can trace the direction of magnetic field means, only two ways is there. One is using compass needle, one is if you sprinkle a iron fillings. Here if you take gently tapped that cardboard, so that iron fillings are make around a circular path, it makes concentric circles. Here we can treat it is the magnetic field lines. So from that we can conclude the current carrying conductor produces a magnetic field.